So we chose to look at two main association mining structures. So the first was the association of categories by company, and the second one was the association of cities by company for all the different job posts from the different companies in the CITS Australia database. So the first mining structure used this data source view. So the case table would be company, and the nested table would be category. In the second mining structure, the nested table was company again, and sorry, the case table was company, and the nested table was all the cities. So if we look at our SQL database here, so these were the three views that we used to create these mining structures. So the first view was category. So for each job in the database, there was a corresponding category, which we're going to be looking at the association for. And for each one of these jobs, there was the company that it was associated with. And this will be linked to the company view, which is the case table, where we have each company ID and the name of the company. At the second mining structure, we have company again as the case table, and the nested table would be all the cities. So you can get all the different jobs here. Each job would have a corresponding city that it's open for, and the of course the company ID foreign key again that links it to the case table. So if we look at Visual Studio here, we can see that for our mining structures for our association of categories, there are 663 rules. If we limit this to minimum probability of 80% and minimum importance of 0.5, we can see that there are only 20 rules that fit this criteria. So, and in all these rules, we have the probabilities on the left, the importance in the middle, and the rule on the right. So for example, the top one, there's a 94.4% chance that if a company releases a job on CITS Australia for construction and hospitality and tourism categories, it will also release a job for trades and services. And secondly, company releases a job for science and technology category as well as education and training. There's a 90.9% chance it will also release one for administration and office support. In the dependency network, it's glitched, but I think this issue was covered in the clarifications. You can see that this node here, the consulting and strategy, it predicts information and communication technology. So we go to our second mining structure here. There are a total of 976 rules. So if we limit that to the same criteria, you can see that there's only 98 now, but there's a lot of rules with 100% probability. So we can interpret this as there's a 100% probability that if a company releases a job in Darwin, as well as Wollongong and Illawarra and South Coast, there's a 100% chance it will also release a job in Brisbane. So we go down, the next job down would be, the next rule down would be the fact that if a company releases a job in Bunbury and Southwest as well as Brisbane, there is a 91.7% chance that it will also release a job in Perth.
All right, so now we'll be talking about the designing and implementation of the graph database. When designing our graph database, we thought about the most convenient way of building it while also being able to easily query the necessary information. So for every column in each row of the CITS Australia file, we have designated its own type of nodes, with the exception of job description, salary, and URL columns. As can be seen here, every job ID can be seen on the job node with the ID and the title here in the middle. And then it is connected to other nodes that represent the different columns on the CITS Australia.csv, same as here. City, same as here. And because the city and the state, they are connected, we have this connection between state and city. So the state is in the state of North Shore and Northern Beaches is under the city state. Sydney. We can also see the time is being divided compared to the one on post date column. The time here is being divided to year, month, day, hour, minute, and second. Now we're just looking at how the nodes are being connected. And here, for example, we've got the first row. The name of the job is Store Manager Fresh Produce. We've got the ID 0, and it is connected to this state. It's also connected to Sydney. It's also connected to this category, connected to this job company, and the time, which is the day 15, hour 23, etc. As an example to show how the navigation works, we are going to look at the query number 2. How it works is that it will match for jobs, and then it's going to look for titles that occur more than once. After that, we've got a list of the titles that appear more than once. After that subquery, we are going to match and look at the jobs that has the same title as the one in the identical job list. And then from there, it will look for the job that has the same title as the one on the identical title list, and it will return those job IDs, as can be seen here, which are very distinct with one another. Another example that we're going to be looking at is finding the top 5 companies that post the most full-time job in the information and communication technology category. So first of all, we have to match all the necessary nodes that are connected to job. We then look for the jobs that are under the category information and communication technology, and that they are also a full-time job. And then we are going to be returning the company that lists those jobs, and also the total amount of jobs that the company posted. And because we only want the top 5, we sort it in a descending order with the topmost at the top. And because we only want the top 5, we're limited to 5.